Our next conic in Chapter 7 is from Section 7.3, ellipses. So we'll have two equations for ellipses, and we're only going to consider those centered at the origin. We want to recognize the equation for an ellipse when it's not in standard form, be able to put it in standard form, and we want to use the equation to tell what the major axis is and where the vertices are. So the definition of an ellipse is the collection of all points in the plane, the sum of whose distances from two fixed points, called the foci, is constant. So notice they've got like a string here and two ends of it pinned down, and they're holding a pencil taut between against the string and drawing an ellipse, so that the sum of these two distances is always the same because it's the same piece of string. But if you use that to draw, it'll make an ellipse. So you have two vertices, and the two foci are where you would imagine the pins are holding the string. Okay, so we'll look at our two standard forms for the equation of ellipse. We're only looking at those centered at the origin. Now, our parabolas moved all over the coordinate plane, our circles moved all over the coordinate plane, but we're going to keep our ellipses here centered at the origin, either elongated on the x-axis or on the y. So let's look at these two different equations. Given that a is a number that's greater than b and b is greater than 0. So what are the a and b? Look at the picture. A is the distance from the center of the ellipse out to a vertex. So from 0, 0 to this point would be move us to the point A0. If we go in the other direction, we're at negative A0 because we're starting at the origin. Likewise, b is a smaller number, and it is the distance to the minor axis, on the minor axis, up 0b and down to 0, negative b. So that holds true for both of these. So in this case, the major axis is the x-axis for this diagram, and for this equation we're going to write. The equation is x squared over a squared plus y squared over b squared equals 1. Always equals 1. The vertices are always at plus or minus a0. So as we saw here, a0, negative a0. And the vertices of the minor axis are these, 0b and 0, negative b. So we'll just focus on the major axis ones here, but I guess we just note that the minor vertices, I guess we could put are 0 plus or minus b. Okay. All right, our other type of ellipse that's centered at the origin, the major axis, is the y-axis. The equation here is x squared over b squared plus y squared over a squared equals 1. And the vertices are 0 plus or minus a, right? Because our major axis is the y-axis. And the minor vertices are plus or minus b, 0. And they're along the x-axis. So notice that's why b has to be the smaller number. So the smaller number squared would be under x here. The larger, because the major vertices, would be on the y-axis.